Assalamu alaikum and very warm welcome to all of you. Today you are going to see in a small video or in animation how the sine wave is produced by mass spring system. You understand sine wave or in general sinusoidal wave including sine and cosine. They are one of the most important signals in engineering. So a fundamental connection, you will learn a fundamental connection between the physical motion and signals. So apart from the sine wave produced by the mass spring system, we will also consider some other systems where naturally we have the sine wave or the sinusoidal waves. So let's first consider the system. Okay, so on the left side you see we have the mass spring system. This is the mass attached to the spring, and this is spring. Whereas on the right side we'll plot its graph. So on the x-axis we have t, and on the y-axis we have its amplitude. So you understand it's a time domain signal, and when we push the this mass upward, so from equilibrium position is denoted as 0, as can be seen here. So when it moves up, the amplitude is increasing, it will be compressed and it will reach some point here. After that it will start decreasing and it will come to the this 0 position or equilibrium position, and after that it doesn't stop here, it will be stretched, and when we move in this direction we plot this one as negative. So you'll see that it basically models the sine wave. Understand this modeling is basically the displacement versus time. So okay, on this axis we have time, on this axis we have displacement, and displacement is, you understand, when we it is compressed the displacement is positive, and when it is stretched the displacement is negative, and when it is at the equilibrium the displacement is 0. So let's start the animation. So you see it's at 0, so this is 0 point, it's going beyond 0, negative side, so it's going moving up, negative side, so it reaches here, so negative peak, and then it moves up. So you see the spring is moving up and down. At equilibrium we have this 0 line, below equilibrium it is negative, above equilibrium it is positive. So you see that the model of this one produces sine wave. So hopefully you understand the idea of how a sine wave is produced in natural system. In this particular example, it is the mass attached to a spring. So you see we have created different cycles of it, and hopefully you understand this one conceptually. Let's have its mathematical discussion now. As I shown you on the previous slide, when the mass is at rest, it remains at its equilibrium position. If you pull the mass away from equilibrium and release it, the motion begins. The mass moves towards equilibrium. It gains speed. It passes through the equilibrium. It reaches the opposite side, and the cycles are repeated. So mathematically, we can write the displacement as x of t, which is a signal, right, is equal to a sine omega t plus phi. So this is the complete description or definition of the sine wave, where a is the amplitude, omega is the angular frequency. We can convert this omega, the angular frequency, into linear frequency, and they have the relationship of omega is equal to 2 pi f, and phi is the phase. Frequency indicates how rapidly oscillations repeat. So there is a repetition, so that means period is involved. So period is the time required for one complete cycle. So t is equal to 2 pi by omega, or omega is equal to 2 pi f. So we can write t equals to 2 pi by 2 pi f, or 2 pi and 2 pi cancel. So t is equal to 1 by f. In the example considered above, we used omega phi equals to 0 because there was no phase shift in the sine wave. It started from 0 and no phase shift. So the example considered for in the animation is x of t equals to sine omega t. Let's consider some other examples where a sine wave is produced naturally. So for example, AC electrical generator. So there we have a rotating coil inside a magnetic field and it produces a sine wave. Similarly, the other example is the tuning fork vibration. We struck the tuning fork and if you observe its waveform, it produces a sine wave. Similarly, the circular motion projection also produces a sine wave, and a simple pendulum you must have seen in the clocks. So a pendulum swinging back and forth produces a sine wave. So that's all for today. In this lecture, you learn a mass spring system performs a simple harmonic motion and its displacement varies periodically with time. So when plotted, the displacement forms a sine wave. We focus on visual understanding instead of memorization. So hopefully these things become more clear to you. You understand this lecture as part of Signal and System Foundation course with Python. So this is the channel address, and that's all from my side for today. See you in the next lecture. Until then, goodbye.